Hey guys, this is the fourth part and the last part of the software development lifecycle. Let's see where we are. So you remember we said we have 7 phases to produce software. So the planning is out of our scope and these two delivery and maintenance as well. So far we finished design and analysis. And now we want to start the implementation part. So actually, except the analysis, we will get back to all of these later, right? Except the analysis and probably testing. Yeah. All right. So first we need to change our hat. Yeah. So now we are developer. Okay, so let's see what is the goal of implementation, what is the artifact, all right? So the goal of implementation is to implement the classes that was discovered by the designer, right? And we already know all of the classes, let's say, yeah, somehow, because it would change during the implementation and the relationship. And we have a simple mock-up so far. Yeah. Okay, so we want to implement the classes, we want to test them, and we want to integrate these classes into the whole application. So what is the artifact of this phase? Obviously it is the code, right? So this is the main artifact of this phase, and probably some README files or something like that would be prepared by the developer. All right, let's see. We said we want to implement classes and then test and then integrate. Let's see what kind of a strategy we can have for this job. So one strategy would be, this is a pseudocode for this strategy. Let's say we have a list of the classes, right? As long as this list is not empty, inside this do what? First, pick one class. Let's say we have one list of the classes. So pick one class, implement it, and then unit test it, all right, and then remove it from the list and go here, pick another one. So the classes will be implemented and tested, and we put them aside. And then when we are out of the, the list is done, we are done with all of the list, then we would go to integrate all the classes, and then, we test entire the software. What do you guys think about this strategy? Is it a good strategy? Let's see. It is horrible strategy. This strategy is called Big Bang integration strategy. This is the worst ever, believe me. It doesn't work, right? Never ever do that. So OOP encourage us to do this. Implement a class, test it, and then integrate it inside the software, and then again test it. But this time test everything, right? All of the previous classes and this one, the whole application. And this is called integration testing. Okay? So how can we write down the pseudocode for this strategy? Yeah, you can pause the video and try by yourself. I put the strategy here. So we have the same loop here, but In this loop, we pick a class, we implement it, we unit test it, right? I will explain the unit testing later, and integrate into the software and test the whole application, and then remove the class from the list. Okay, so this is the best way to develop your application. So this is actually incremental way. We increment the application step by step. So what was the markup? You remember we said the functional spec contains markup prepared by who? The BA or business analyst, right? And also possibly in the technical spec it might be enhanced a little bit. So this markup, as we said, it's really helps the understand, to understand the problem, and also it facilitate the process of implementation, because the developer has a view about whatever he or she wants to produce. All right, so before uh, you know one person could play all of these roles. BA, when I say before, it was, many years ago. So one person was the BA designer implementer for most project, not big project, but for most project, it was really a one-man show. So in that time, I remember that, uh, you know, a simple version of the software was produced by who? Developer, right? And that was equivalent the mockups that we are talking about right now. At that time, we called it prototype. Yeah. Honestly, I don't know whether it is still popular or not, but at that time, developer prepare a very simple version of the software, and we called it prototype. All right, and it was somehow equivalent to the mockups that we have right now. Okay, so the other thing that you need to know is code is not, I mean, coding is not a linear progression. I mean, it's not a linear. All of these phases that I just talked during these three lectures, and this is the fourth one. It's not a linear progression. I mean, um, the code will always change. It always evolves over time. Uh, in other words, the software grows up exactly like a human, right? Exactly like a human. It is born and it grows up, and it will be mature, and if you don't take care of it correctly, it will die. All right. So when I say it looks like a human and it grows up, how it is possible for a software? So when a software is produced, it means that it is born, right? After that, new requirements comes from your client. So these new requirements needs to, change the code, all right? And also, you know, y- these requirements might be some new enhancement or some new really features that you need to add to your code. Okay, so bottom line is the code is always changing, exactly like a human, right? You know, change is something that unavoidable. And when the software is changing, it will become more complex. All right. So change and complexity is two phenomena for us, right? So If your software is gonna live for a long time, it should cope with these two phenomena. What? The non-stop changing and increasing the complexity. Okay, so this is the reason of dying some software, and there are a lot in the history of the software development. Many companies went down because their code could not tolerate change and becoming more complex. All right. So in the past 3 decades, even more, um, object-oriented showed that it can deal with these two phenomena. And that's why it is still alive and it is still the dominant paradigm in the world. Okay, so we are not done yet here for the implementation. We will get back to the implementation later. But before finishing this section, let me tell you some, somehow true story. Okay, so what would happen in the real project? Yeah, so the next slide looks like a joke, but believe me, to an extent, they are true in real projects. Yeah, they are a little bit exaggerated, but believe me, it is true, right? Okay. Now, let's see how different team members uh, look at the software and what is their their explanation about the software. Okay, so this is whatever the client explains, and this is the understanding of BA. I hope that it is not true, but with the exaggeration, yeah, totally different thing. This is whatever the designer design, and what is the thing that developer code and develop. And this is whatever the QA receives. And this is whatever the business consultant describe. Yeah, they are usually a liar. And this is how the code is documented. Yeah, I know developers usually hate documenting. And this is whatever is installed. This is how we charge the client, and this is how it will be supported. This is how it was advertised, and this is whatever the client wanted. This section is the last section of this topic, testing. Let's see what we got. So first, we need to change our hat to quality assurance, but that hat could be for the developer as well, because the testing that I'm gonna explain in this section is not really for the department of quality assurance. Yeah, let's see. So what is the objective of uh, this section? Yeah, again, this is our 7 phases, and now we are here, and that was the last phase of our software development, life cycle. So, first question, why testing is important? Oh, it is very important, people. Very important. Believe me, it's one of the most important phases. Okay, so it is so important that companies, first of all, they have a separate department for that, and also Most of the companies will hire some independent companies to test their product. Independent companies, you see, the third party uh, companies, just for testing. All right. So yeah, that's the importance of the testing. And believe me, it's a huge topic. And again, in this course, we need to, cover a brief stuff. So it's just a taste of testing. Okay. I hope that some of the other topics of testing will be covered in the software engineering course. Okay, so let's first say that what's the definition of testing? Testing is a systematic attempt to break the code deliberately, on purpose. We want to break the code, right? We want to find the vulnerability of the code. So that's why we attack the code by some testings. All right. So, now maybe you ask, okay, so what's the criteria for this testing? We are comparing the applications with what? Yeah, we are comparing whatever we uh, promised in the functional spec. Okay. So functional spec is actually our criteria for testing. All right. And any deviation between the current software and whatever we promised in this functional spec will be called a defect. All right, and that's a violation and it should be fixed. So what type of testing we have? There are a lot. So here are some of them: unit testing, integration testing, smoke testing, regression testing, stress testing, user acceptance testing or UAT, okay, alpha and beta testing, and there are more. Yeah, really, really, there are more. But the only thing that is in our scope is unit testing. All right. And in unit testing, it's called developer testing. That's why I said that this testing section is not really for the QA department. It's for our developers part. Okay, so let's see what is unit testing, and to answer some questions like what. First of all, what is that? Unit testing, we test all the units. What is units here? Yeah, methods, for example, or the object, the classes, the packages, the layers. All of these are called units, right? And yeah, probably mostly we focus on the methods, but since objects and packages and layers and etc., they are also units of the software. We can, as the developer, test them as well. Who is in charge for this part? Yeah, definitely developer. Why we should do that? This is obvious, right? So we individually check or test the units to make sure that units per se individually are fine. When this testing happens, two different phases we can do that. So first of all, in the implementation, when you are creating a class or method or whatever, right? And also in the maintenance phase. In the maintenance phase, uh, you are gonna fix some problems. You are gonna enhance the current features, or we want to add some new features, or you are gonna migrate the software into a new technology. So all of these stuff happens during the maintenance, right? In that case, unit testing is one important part of the development. So before going further, we need to learn two new terms. Expected value. What is expected value? When you are testing, you expect theoretically that that unit, uh, if it is a method, let's say, it should bring or return a value. Okay, so that value that you expect to get from that method is called the expected value. The actual value is whatever, when you run your code, you will get that value. So this guy is expected value. Theoretically, you expect to get that value. This is whatever you actually get, right? And these two values should be definitely equal. If everything is fine, then these two values should be equal. Okay. In this section, I'm gonna explain the JUnit 5 framework for testing and unit testing. So JUnit 5 is a very popular framework, and its job is to organize your test cases outside of your source code. And this strategy will make your code a very neat code. All right. So JUnit 5 is also called Jupiter, and maybe because the Jupiter is the fifth planet in the solar system. All right. So this is really, really a huge framework, very huge framework, and to teaching it needs a lot of time. So here I'm just gonna give you a taste of that. So just a few features of the JUnit 5 framework. Okay, so I'm gonna show you everything in via a live demo. So I'm gonna write a code by using the Eclipse and show you how you can create a test case in your code. And the next slides, the next 4 slides, contain some information that I will try to explain them during the live demo. Okay, let me bring up my Eclipse. And here I want to start from the scratch. Let me close this guy, close project, and then we go to the new project. So the project I want to mention here is the Maven project. It's a huge difference if you say as a developer that you know Maven. Maven is a cutting edge build tool, and knowing it is a must. All right. So here is the Maven project. You can search for that. Okay. So create a simple project for now. Um, Next. So we need a group ID for that. Let's call it, for example, adder. Okay, we would need an artifact ID, which is somehow, it looks like a package, but it is, a little bit different. So let's call it edu dot sjsu dot cs151. Okay, so the version will be, yeah, that's okay. We don't care about that. Packaging is jar, right? It can be other things, but out of our scope. And that's it. We can finish this like this. So the project will be created, and let's quickly see what's the structure, the folder structure of this project. As you see, we have Java source main Java that you put your application here. So we have source main resources. In this folder, you're gonna put all of the resources of your application, such as the messages, such as the configuration file, and something like that. And here you put all of your test cases. That's the beauty of the Maven, that separate everything by itself. And here is the source test resources. If your test cases need some resources, you put them here. All right. So now it's time to create a package here. So let's see. The default package is the name edusj cs151. Yeah, that's fine. We can uh, accept that one. And also, we need to create a class. Let's say we are implementing a class and we want to create test cases for that. So I'm going to create a very simple class. Let's name it adder. I want to add two numbers. Yeah, it's a very huge project. So the adder is public and the rest of that is fine. And the package is fine. Yeah, we are good. So our adder class is created now. All right. So I'm gonna create a public method. This is the method that I want to test. Uh, it's gonna return an integer for simplicity, and it is called add, for example. Yeah, it has two integer a comma int b, and then it's gonna return uh, a plus b. Very simple project, very simple method. Okay, so this is our class, this is our method. Now we want to create a test case for that. So we go to the class, right click here, new, and the JUnit usually does not show up here, but here it is showing up. But if it doesn't, right, in your Eclipse, it might not be here. You go to the other, and here you just search for the JUnit and pick this one, JUnit test case. Okay, we need to set up some stuff. So some of the parameters should be filled out here. So first of all, new JUnit 3 test, new JUnit 4 test, new JUnit Jupyter test. Yeah, we are gonna use this one. Source folder is good. So, you see, it is putting, the source test Java, all right? And the package is good. You see, the name is the name of the class, and it added the test as a prefix to that. That's fine for us. And the rest of that is fine. Let's see next. And these are the list of the methods that exist in your class, and you want to create a test case. For us, it is just this one. So we pick this one and the finish. And now it's complaining that JUnit 5 is not on the build path. So it means that the library of the JUnit 5 as an external dependency is not, does not exist here. We need to add that. We would say, all right, yeah, open the build path and I will add that. Okay. Okay, you see here the libraries. We already have the Java library. Yeah, it is 1.5 that it should be changed. And also the Maven dependency is here, right? These are the external thing. Actually, Java is, the native thing, but the Maven is an external thing that we added here. So we go to the add library, and JUnit, we find there are some, several libraries here. We pick the JUnit, go to the next, and we pick the version of the JUnit that we are gonna add, and JUnit 5, and everything is fine. So this library is being added inside the libraries. Okay, apply, apply and close. Okay, so what happened here? So it created a test class for us that we are gonna put all of the test cases for that particular class here, right? So if we have more methods, we add, you just copy and paste, or we can go to the, the following the wizard that we saw so far. It creates something like this for us, all right? But it is not finished yet. We need to add some stuff. But to be able to see everything side by side, let me put this method here. In this way, we can have a better view what methods we are writing the code. Okay, so something that is bothering me is this Java library, which is 1.5. This is Java 5. So let's go ahead and modify that. We go to properties of the project, and we are gonna find the Java compiler and Java compiler here, and then we will be using the 1.8, which is my favorite Java. Say the compiler settings have changed, rebuild the yes. We still see that the library is still 1.5. That is weird right now. All right, let me fix that. We are gonna go ahead and change the library. You see, yeah, we didn't notice that. No problem. I will add the another library, the JRE system library you see here. Next, and workspace default JRE. Yeah. So if you are gonna add the JDK 8, then if it is already is your default one, yeah, you can say, okay, use this default one. If it is not, and if you prefer another thing, yeah, you can go ahead and find it by, the installed JRE and so forth. All right. So in my case, it's easier because that's my default one. So you see, it adds the library 8, and now I don't need that. I remove that and see what would happen. As you see, the JRE is changed to JDK 8. All right. So let's get back to our test things. Uh, you see here we have an annotation. All of the annotation start with at sign. So this at test for the JUnit, you know, as a JUnit terminology, it means that this is a test case. All right. If you add some other stuff here, I mean some other methods, what whichever that has this annotation, then when you run your test case, all of them will be run. All right. So let's first create the first one and see what would happen. So this is not required. Okay, so first I would need to instantiate this class here. Uh, so adder, let's call it adder, equal to new adder. So the constructor is simple. We just add that. Now we want to call this add methods, which is this one, and we want to pass two numbers and see what would happen. Let's say for example, we um, pass 5 and let's say 3. Okay, so up to this point, we just calling that method. It doesn't do anything. Let me assign it to something. For example, it in int let's say result equal to this guy. Okay, so now we want to check that this add method is working fine or not, right? So we expect to receive 8 here. How can we check that here? We should tell uh, the test case that, okay, I'm gonna compare this 8 with the actual thing that's coming. So the theory is telling me that the result should be 8, right? But the actual is coming from this result, right? So I should, compare that somehow here. So if as a rookie, approach, you can say if, for example, result unequal to uh, 8, then do something. Yeah, that's not gonna work. It works, but it is a rookie approach. So what is the best approach here? Using the assertion. The assertion. So JUnit introduced some assertion. Let me use one of them. So we would say assert, let's see, assert equals. You see how many assert equals is here. So I'm gonna use the one that you can compare several data types, characters, double, float, an integer, byte, and so forth, right? I'm looking for this integer guy, all right? So this integer guy. So assert equals uh, here I need to put the expected value, which is 8. So this is the expected value. And the next one will be the actual value that is coming from that result. So, so this assert job is to compare this and this. And if they are equal, then it will give a green light. Otherwise, it will give you a red light that shows that something is wrong. Okay, so let me run it here and see what would happen. So we need to run as a JUnit. Remember that. Okay, okay, we got the green bar here. Okay, so to show you that if it is not the case and if it fails, for example, as an example, let's say you expected to receive 9, but the result is 8. Yeah, just as an example, and see what would happen. You see, you get a red line here. It means that something is wrong. Another version of this assert is you can add a message here. Uh, to make this message that is coming here a little bit more descriptive. So for example, uh, this is not what I expected. This is just as an example. Yeah, I want to show you that this will be shown. Okay, let's run it and see what would happen. All right, so as you see, this message appears here. This is not what I expected. And then it is saying that the expected value was 9, but we get 8. All right. Okay, so this is whatever I wanted to say about the test cases. You might have added another test cases. Let's say if you have just copy and paste another one. Yeah, actually we need to, rename one of these. Let's say uh, test at 2. In this case, we want to, uh, so let me return it back to the 8. And this guy, let's say we want to add 10 and 2. And we expect to see 12 here. All right. Okay. Uh, Now if you run the test case, I mean the test, this JUnit test, then all of these tests will be run. All right. This is a best way to keep our test cases, and if we add or remove something from our classes, then any changes of these classes, then we need to run the all of the test cases to see that the class is still healthy or not. All right. Um, okay, so now let's run everything here. Yeah, you see, all of these test cases will be run. If one of them fail, then uh, it will show you that which one is failing. Okay. Uh, the other thing that I want to show you, the uh, Jupyter assertion. So let's say Jupyter assertion Java doc. Yeah, exactly the same thing that I am going to find. So yeah, exactly. This is the Java doc of the class assertion. You can go over this and you see how many assertion we have. We have assert arrays. We have um, the assert equals that we just use them, and there are a lot of other things. Yeah. So for many situations, you can use this assertion. You see, it's a long list of the assertion and the long list of the methods that you can use. The one that we used was assert equals, yeah, so you see the assert equals, you hear byte, char, and so forth, right? The one that we used was this guy. Assert equals int expected and actual, and this one that we added a message. All right. I'm gonna stop here, guys, and see you guys in the next lecture.